Assalamu alaikum. In this video, we are going to start our first chapter, Roots of Polynomial Equations. So, first of all, we will do a discussion about the name of the chapter. So, the name of the chapter is Roots of Polynomial Equations. We will discuss the word roots later, but before that, we are going to discuss polynomial equations and we will discuss it in detail. What are the polynomial equations? The polynomial equations are algebraic expression. Algebraic expression. Wait for a bit. Oh, sorry. Algebraic expression and it is made up of, now we will discuss how it is made up of. It is made up of, we will discuss now some pointers. It will made up of, wait here, one or more variable, it is made up of one or more variable. Now let's have a view on the examples. For example, x equal to 0. It is a polynomial equation because it has one variable. Then wait, let me give you one more example here. X plus y equal to 3. This is also a polynomial equation because it is satisfying more variable condition, one or more. In this there was one variable and in this there is more variable. Okay, let's move to the second point. It says there should be sum of terms. Let's get to the examples. For example, 3x plus 5 equal to 0. Now we will consider both of the conditions. First of all, we will check, are there one or more variable? Yes, there is one variable, so it satisfies the first condition. Then the second condition is sum of terms. If you notice, there is sum of term. The first term is 3x, second term is 5. They both are getting added and then 0. So this is a polynomial equation. Then the second example is 3x plus y equal to 0. So let's first check out the first condition, one or more variable. One variable and the second variable, it satisfies that one or more variable. Then look at sum of terms. This is the first term, this is the second term, so yes, and this is sum, so yes, it satisfies the second condition, so yes, it is also a polynomial equation. Let's go through the third example. 5x minus 8 equal to 4y. Let's go to the first condition, one or more variable. One variable, second variable, so the first condition is satisfied. Let's look at the second condition, sum of terms. This is first term, this is second term, this is 4y is the third term. Let me repeat, first term, second term, third term. Okay, and the what we have to do, sum of terms. The negative sign means Subtracting. What is meant by subtracting? Subtracting is just adding a negative number. It is like this: 5x plus minus 8y. It is just like this. Subtracting is just adding the negative number. So yes, here is also sum. Here is also sum of terms. So thus this is also a polynomial equation. Now let's move to the third and last condition of determining if the equation is polynomial equation or not. The third condition is positive integer power of variable. Yes. So let me tell you that in the third condition there are two conditions. First, the power should be positive, and the second, the power should be an integer. Let's have examples here. First example is 3x square plus 2x plus 6 equal to 0. So we will check one by one all the conditions. First condition was one or more variable. There is one variable. Okay. Then sum of terms. Yes, the first term, second term, third term, and all are getting added. So there is sum of terms. Then the third condition is positive integer power of variable. Positive. First we will check positive and integer. These both should be simultaneously checked. There is 2, which is a positive integer. Integer are 1, 2, 3, 4, 5 and 0. Okay. So positive integer, it means the 2. So it satisfies the third condition. Here is 1, positive 1, so it also satisfies the all of the conditions. So it means this is a polynomial equation. Let's check out the second equation. 9x cube, wait, now last time, yes, 9x cube plus 7x plus 3 equal to 0. So first condition was one or more variable. There is one variable, there is the same variable, it means here is one variable which satisfies the first condition. Second term, sum of terms. First term, second term, third term, and they are all getting added. So it means it also satisfies the second condition. Now let's check the third condition. Positive integer power. Positive 3, it means positive power and an integer also. There is positive 1, so it also satisfies the third condition, which means this is also a polynomial equation. Let's take these two equations. Now the third equation is 5x 1 upon 2 equal to 0. Is it a polynomial equation or not? First check the first condition. One or more variable. Yes, there is one variable, so first condition is correct. Now sum of terms. Are there any sum of terms? In reality, yes, it is like this: 5x 1 upon 2 plus 0 equal to 0. So yes, it satisfies this. Now let's look at the third condition. It means it says positive integer power, but integer are 1, 2, 3, 4, etc. 1 upon 2 is not an integer, it is a real. So thus this is not a polynomial equation, so cross it. Now have a look on the fourth example. 5x 1 upon 2 plus 8 upon y equal to 13. First condition was one or more variable. Yes, one variable, second variable. It satisfies the first condition. Then second condition, sum of terms. First term, second term, and they are getting added. It means sum of terms is also satisfied. Now let's have on the third condition, positive integer power. That is positive but not an integer. So yes, it is not a polynomial equation, but let's have on this. So it is 8y minus 1. There is integer but not a positive, that's negative integer. So thus it is not a polynomial equation. Wait for a bit. Okay, this is not a polynomial equation. Now let's move ahead, and that was the complete discussion of polynomial equation. Now you have the idea of what is a polynomial equation. Let's get a review. I think now it should be algebraic expression. What is algebra? Yeah, when there are the mix up of number and the alphabets as a variable, constants and variables also. Okay, we can also define this constants and variables, and we can also say this alphabets and digits. Okay, and the second point was made up of three conditions: one or more variable, sum of terms, and positive integer power of variable. Okay, so now we will move ahead, and now we will discuss roots. But here I will not directly discuss roots. I will also discuss roots and coefficients, both relation between roots and coefficients. So let's have a discuss of roots. Wait, yes, roots. What are the roots? And give me a second. Okay, yes, roots. What is roots? Basically, roots are answer or solution okay, we will discuss. And the second word is coefficients, which have a very vital role in this chapter. Coefficients are a number or anything, or a number, basically a number. It can be integer, it can be real. Okay, a number with a variable. For example, a x square. So a is the coefficient, b is the coefficient, only c, because c is with cx power 0. So these are the coefficients. Let's have an example. We have an equation x square minus 5x plus 6 equal to 0. We will solve it. How we will solve it? We can use quadratic formula, we can use middle term breaking. So we are going to solve it using the middle term breaking. Here we will write x square minus 3x minus 2x plus 6 equal to 0. Then we will take x as a common, x minus 3, and here we will take 2 common, minus 2 common, it become x minus 3, and then equal to 0. Now we will write x minus 3 and x minus 2 equal to 0. So here we got that x equal to 3, but before that I am writing it as x minus 3 equal to 0 and x minus 2 equal to 0, and then x equal to 3, and here also x equal to 2. Okay, so these both are the roots. These both are the roots. Okay, so these both are roots. And let's talk about the coefficients. The coefficients in this equation. If we talk about the coefficient, here is 1 with the x square. When there is nothing with the variable, it means there is a 1. Okay, so there is a 1. There is a negative 5 with x, and there is 6. So let's write the coefficient. The coefficient are 1, negative 5 and 6. Okay, till here. Let me give you a review for this roots and coefficients. We started to discuss roots and coefficients. Basically, roots are answer and solution of the equation, and the coefficients are number with the variable. Okay, so here this was the equation. It has coefficient 1, negative 5. This sign will be considered negative 5, and this 6. These three are coefficients. We solved it using middle term breaking, and we got two answers, 3 and 2, which are roots. So that was our discussion. Now let's move ahead. These were only the discussion about the name of the chapter. Now I will tell you about what are the topics, how this chapter is divided. Basically, this chapter is divided into 4 topics. Let me tell you their name. Yeah, there are 4 topics in this chapter. Wait, here, am I out of the line? No, I think no. Okay, so let me write ahead. Yes, the first topic we will do is quadratics. Wait, the second topic will be cubic. The third topic will be quartic. And the fourth topic will be substitution. Okay, so now after covering these 4 topics, we will be able to achieve 7 to 8 marks out of 75. So let's start our first topic, quadratics. Wait, here, yeah, this is. So quadratics is our first topic, and now we are going to start this. What is quadratics? Where the degree of polynomial is 2. Degree of polynomial is 2. Let me show its general structure. Its general structure is ax square plus bx plus c equal to 0, where the maximum power of x is 2. Okay, so now let's derive the formula for this chapter and quadratics. Okay, so the formulas are very important in this chapter. So let's start here. Ax square plus bx plus c equal to 0 has roots alpha, wait here, alpha and beta and beta. These are two roots of the equation. Okay, so how we will do it? What we have to do? We don't know. Let me tell you, in add maths, O level add maths, and sometimes in A level maths, the question 2 or 3 question was appeared like that. The 3 and 2 was given, and we have to find out the equation. So how did we do this? We have x equal to 3 and we have x equal to 2. How do we do this? We will move this 3 to the left, and here also x minus 2 equal to 0. So we are at this position. If we are going back, we check they both get merged. Okay, so we will merge both of them. We will write them as x minus 3 and x minus 2 equal to 0, and then we will expand this, so we will be back with this equation. Am I right? If you are not sure, you can expand this, but I am moving back to the quadratic which we were discussing here. Okay, we were at this point. Ax square plus bx plus c has roots alpha and beta. What we will do? It means we have x equal to alpha and x equal to beta. Okay, we will write x minus alpha equal to 0, and here we will write x minus beta equal to 0. So now we will merge both of them. X minus alpha multiply by x minus beta and equal to 0, and then we expand x square minus alpha x minus beta x plus alpha beta equal to 0. Just we expanded this. Then we will do minus, we will write in this square plus bx plus c. Okay, so minus was taken common, then alpha plus beta. Wait here. Yeah, if you are confused what we did, if you multiply this, minus alpha minus beta x minus alpha x minus beta x, so x and minus are taken common here, then plus alpha beta. So now what we have to do, we are going to deduce our formula, which is not a part of the syllabus, just we are doing it to memorize the formula and how the formula was expected. Now compare it with ax square minus bx, ax square plus bx, that's a general equation of quadratic, equal to 0. Here we notice there is 1, so we can also turn it 1. How? Divide the complete equation by a, x square plus b upon a x plus c upon a equal to 0. Okay, this was like this. We divided the complete equation by a, so it was also get divided by a, and this a got cancelled. So that's why we have this form. Okay, now we will compare that x square is equal to x square. Okay, and then we compare negative alpha plus beta x equal to b upon ax. So we got a formula that negative alpha plus beta x equal to b upon ax. This x and x got cancelled, so it become, and the minus will get shifted to the right, so it become alpha plus beta. Wait, let me write it nicely. Alpha plus beta equal to negative b upon a. So that's our formula, and we can write alpha plus beta as sigma alpha equal to negative b upon a. So I prefer memorize formula as sigma alpha, okay, or summation of alpha, like this, instead of alpha plus beta. Then move ahead, we can compare this also, that alpha beta equal to c upon a. So we got the second formula, that alpha beta equal to c upon a. So we are ready with formula here. So these two are our formula which will be used, and I am also introducing one more formula which will also be used. So if we will have any other formula, so I will tell you later. Okay, I think we should do question. I am not introducing the third formula, I will introduce it later. So currently we are going to move to the question. Let me copy out the question from the book. Wait here. Where, yeah, there is an image. Complete. Yes, so this is our question. Let's do this question. The question is saying each of the following quadratic equations has roots alpha beta. Find the values of alpha plus beta and alpha beta. So just we will use these two formulas. So let's do the part A. It is asking to find alpha plus beta. I told you that alpha plus beta is this, sum of alpha. So we will apply the formula sum of alpha equal to negative b upon a. Okay, so what is b here? If we look at this, a equal to 1, b equal to 5, c equal to 9. Okay, so sum of alpha equal to negative 5 upon 1. Okay, B and A. So the final answer is negative 5. Then we will also do alpha beta. The formula for alpha beta is C upon A. So what is C? C is 9 and A is 1. So we will write it as alpha beta equal to 9 upon 1, which is equal to 9. Okay. Now wait for a bit. Now move to the part B. In part B, the A is 1, here is 1, B is negative 4 and C is 8. Okay, so we will apply the same formula, sum of alpha equal to negative B upon A. So negative 4 upon what was A? A was 1. So here the answer will be minus minus plus, so here will be plus 4. Then if we move to the alpha beta, it is C upon A. C is 8 and A is 1, so it is 8 upon 1. So it become 8 as an answer. Okay, so let's move to the part C now. Here in part C, the A is 2, B is 3 and C is negative 7. So let's do it. Sum of alpha is equal to B upon A. What is B? B is 3, A is 2. So we will write 3 upon 2 here as an answer. Sorry, my mistake. It is negative B upon A. So it is negative 3 upon 2. Now alpha beta is C upon A. So negative 7 upon 2. So that's how we have to apply this formula. Okay, I did a mistake. Okay, I have to do this below, but I don't know can I do this or not. So currently leave this and move ahead. Now move to the second question, but I think now we will do the second question in the next video, and we will do few more questions, not only second question, we will do few more questions in the next video, and I will tell you one more formula in that video also. So thank you for watching this video. Like and subscribe the video and stay connected for the further videos. Thank you.